Great. Okay. So now, guys, a couple things that may have changed since our last video is I actually slimmed down the footprint of the main. And a couple things that I've deprecated or put into comments are some of these random numbers. And what I've done is I've moved the randoms over to the stock. But I've said, well, I can simplify. And what I had is I had this stuff sitting, right here. And what I did is I actually removed a lot of that complexity and I put it inside of the set stock price right here. And so what I'm saying to you now is there's kind of a lot of messiness that's happening inside of the constructor. And what I would like to propose is to clean it up a little bit. Yeah. So what I want to try to do is I want to try to use these functions right here. But let me just say that we haven't really done a discussion on functions. Functions are one of the cornerstones of programming. And I think the reason why is because pretty much everything that you can do inside of mathematics, you should be able to do inside of programming. And this is why, when it comes to programming languages, all programming languages really have the similar mathematical capacities. I mean, I always have these debates where students are like, "Oh, should I be learning Python, or should I be learning R, or should I be learning C?" And those are great questions that a lot of my best students ask when I first come in. And usually I'm saying, well, no, you should just use Java to do everything, to make your websites, to do your Android, to do your machine learning, to do all your statistics stuff, all your big data. But there are certain communities of researchers who really like to focus on languages. And the reason why is because upper tier computer scientists are busy writing new languages all the time. And in order to hone that craft, like Python has a lot of very specific capabilities that it can do better than Java. So a lot of early search engines were big on Python because Python would go there and ingest the HTML from a website and would give you a better environment for analyzing the content of that website. Now, Java does that kind of HTML ingestion as well as any other given language. So I think what you should be thinking about is just do everything in Java. Don't have the belief that somehow a language in itself gives you capacities that other languages do not. The exception being when you get into different devices. Like I had a good buddy who was talking about a rifle that could automatically locate a perfect firing solution that had a Linux computer built into the rifle. And I was thinking, okay, well, that may have a limited programmability because of the context of the device. The device is just like a Raspberry Pi that's located in a rifle. That's pretty exotic. Now, take a Samsung cell phone. Well, that device, an Android device, requires the Java language to build for Android. It can't use C or C++. It needs to have that Java. And similar constraint for the iPhone, where you have Objective-C and Swift for the iPhone, and Java, you can't use that for the iPhone. So really the device defines the programming language. These days, 98% of objects on planet Earth are personal computer, Intel architecture things. So even that programmable rifle, you could probably insert Java to write for it. So unless it's a very closed ecosystem like a Android or a iPhone, Java is useful for 99.99% of programming applications, be it big data, machine learning, AI, games, sure. So let's just put the rest, whether one language or another is necessary. There's only one language that you need, and that you could do your entire CS on Python. Some schools do that. It's great. There are others, like you go to UCLA, they are using all, Smalltalk, or they're using all one language. That's great. That's what they choose to do. That they should have latitude to do that. But let's go through this. All programming languages must have a couple of building blocks. One is the ability to work with data types, integers, doubles, floats. Two, they all must have the ability to do if-then or if-else. Three, they must have for loops and iterators. Four, they must have functions. Five, they should have some object-oriented capacity. So if you have those 5 basic knowledges, you know that language. And so by the time that you wrap up these YouTubes, you will know 95% of the Java language, within the first month of the class. That's perfectly reasonable for students to learn those 5 cornerstone building blocks. That's data, data types, if else, for loops, iterations, collections, methods, and classes. And when you have these wonderful PhDs from Yale who teach you, such as I had, and I value them greatly, they made it very clear that by now you've learned all the language. And so you will reach a point in this class where I say, guys and girls, you've learned 95% of Java. There's very few problems that you could not solve. All of your problem solving will loop back to your strategy and your algorithm analysis. Okay, so just hang with us a little bit. You're getting close to 25% of a lot of the programming skill set. So just hang tight. Now, the reason why I say that long talk is because we need to get you guys doing functions. So for example, you see here, we used to do the stock. If you look at your current stock, probably you're setting, you're doing price is equal to 55.00. That's fine. But what we actually want to do is we want to employ the random so that we get an unpredictable yet reasonable value, and then we want to set our price to that random number. So here I'm just going to create a new stock. So the main is now very stripped down, and a lot of the work is getting done inside the class itself. So that stock class is taking on some robust new sophistication. So let's go ahead and run that a few times, and let's just kind of study that. So the stock price is this. So that comes from this system out right there. And probably, and if I run that a few more times, you can see that the stock price, every time I run it, it's a new stock price. So you can have some faith that your random is firing, and that when you call this function set stock price, that is firing also. So let me just take it out, and just to prove to you that function is meaningful and firing, we'll go ahead and run that a few more times. Now I may have lost my console, so I want to show the console. And let's run the Brain Center. And here I am running it, and I'm like, wait, nothing happened. And that is precisely what it's supposed to do, because I've turned off set stock price, and also my main, I'm not asking for anything right here. The only thing I'm doing inside of main is just saying, hey, create a stock, please. So let's turn that back on, and you realize now the system out is forcing some output to the console. So I'm just putting that out there just because it benefits being said. But what about that IPO quantity? I should be able to set that IPO quantity. So I'll set it to private. Then I'm going to set it a little bit differently. I'm going to set that's an integer, correct? Why don't we say I want for this function to deliver an integer, and I'm going to set the IPO quantity, and I'm not going to take any parameters. And what I'm going to do is I'm going to set up an integer called return value, and I'm going to set that to 0. And then at the bottom of the function, I'm going to say return value. Now I could say something different. Like I could say that return value is RV, and you could return RV, and that just causes Java to stop complaining, because when you say that you're going to return something, you kind of have to return it. So when I comment that out, Java is going to start to complain. It's saying, hey, I'm expecting for you to you need to add a return statement right there. So you can sort of add a return statement, and it's going to do that work for you. So a smart strategy is when you're constructing a program, go at it with the sense of, okay, I'm going to define my methods first, and then I'm going to fill in a couple lines of code for each of my methods. And so what I'm going to do here is I'm going to say my IPO quantity, I need to set the IPO quantity, and I'm going to set that equal to the results of set IPO quantity. And I have the two parentheses there. So I've set up a nice architecture for my constructor. You know, my constructor is this kind of thing with the empty parentheses. It's the first thing that throws when we create the object. So right now I have this nice strategy where I'm going to call upon these methods. So that also helps me to debug stuff. So if I have something that isn't quite working quite right, I can localize the error and I can fix the error in a simple way. So let's do this. Let's set up a new random right here, which is going to be a new random. You know, I have to do that. And then why don't we say the RV, that's what we're going to return anyway, which is going to be equal to r.nextInteger. And why don't we create a limit of that to be 15 million. Usually an IPO is a large number of stocks initially sold by a bank to the market. And that's a big moment, and then we can return RV. So you can see here that when I save it, I don't have a lot of warnings, I don't have a lot of red lines, but here's something nice that I would like to do that would, every time I'm creating a new variable, I want to supplement that with a print line so I can say my IPO quantity is set to, and I'll go to RV. And the reason why I want to show off and test RV is because I'm going to pass RV back to IPO quantity. This is the RV value from set IPO quantity. And let's go ahead and run that and see if I'm making any mistakes. Okay, so I've got a stock price, which is coming in from set stock price, right? It's going to call set stock price. And then I've got that IPO quantity, which is going to be set when I call IPO quantity. Now, talk a little bit about the difference here. This function is going to call set stock price, and it's not going to return anything. When we do a void, void returns nothing. A void just simply operates without retaining any memory. So when we say void, we're actually saying don't save any memory, just do something mechanical. But what's interesting is the reason why I get price is because I set it right here. And price was defined earlier up at the top of the class. So because I have price defined up here, I'm able to set it anywhere inside of that class, and then I can get the job of defining that. I can finish the job of defining that. And so that's a little different from IPO quantity, which IPO quantity is defined here at the top of the class, right? It's a member variable, but I'm going to use set IPO quantity to initialize it. So these are set two different ways. So here are two different ways of initializing your member variables. Okay. So let's go ahead and run that again and show off what we got. So this is all very important. Now, just as a way to show off a little bit more, we can turn these printing statements off, right? And then we can employ them here, where we can say, system out of the print line, price is now L dot price, and we could say system out dot print, just to skip a line. We could say print line, system out dot print line, and that IPO quantity is now set to L dot IPO quantity. So these are two important statistics that are set by each stock when we want to create it. So let's go ahead and compile that. And so you realize that we're getting those randomly determined variables in different places, and we're testing them in different places too. So here's a quick comment. This kind of printing is okay to do it right here, but we could also remove that, because having a nice, clean, simple main is something that we take pride in. Because another programmer could say, okay, your main is very, very simple. All your work gets done inside of the stock class. Now what I could do is I could actually do these system outs right here. And we would avoid the L because we haven't created that new instance. And you realize that we're getting that same output. But let me just show off just one little bit more and create another void method that says print price and IPO Q2Y. And let's just say, okay, well, we could also place that rather idiotic but useful code right down here. So as long as we called print price and quantity, we would get those things. So when I run this, you realize, oh no, I'm pressing the button, nothing's happening. Because actually, if I don't use print price and quantity, nothing happens. So what I'll do here, and let me have you pay attention to this. Notice that I have a public right here, but these are private. I can call set IPO quantity from within the stock class because I define it here, but I can't go L dot, it's not there. I can't call that from outside of that class. So none of those private functions and methods are the same thing. None of those private functions can get called inside a main. They can only get called in, its proper class. So let's say I've got this very valuable method that I want to call. Well, what I'll do is I'll call it public, and then I can say, and I believe it begins with a P, print price and IPO quantity here. And let's go ahead and activate that. Great. So now we're doing what we needed to do in a really nice way. But really the emphasis here is, guys, please think about making lots of methods, lots of functions. If you make functions, I will come by and give you a high five. Functions are professional programming, and you're using the power of the language. Architecturally, it's simple. And your architecture is really what you're going to be graded on, is how sweet is your building process. So methods are an important tool to building nice structures. Programming ultimately comes down to a small skill set. Architecture is a larger skill set than the programming language itself. You will spend more time in your undergraduate talking about how to architect programs than you will actually learning the core language. Because we can teach you the core language in 2 or 3 weeks. Does that make sense? And we will be taking it easy on you. A good programmer, someone who has been taking this class, you can learn Python in a day. Like, take your Saturday afternoon. You can learn Python, right? Having this 10-week class, though, is what enables you to learn other stuff later. So just to summarize, here's a private method. Only the class can call its own private methods. The other classes can't call it. And then you got a public method. Other classes can call upon that public method. So for the purpose of this class, stuff that's public is a little more convenient because that data can be shared across your application. Folks like it's at Facebook, and there are hundreds of thousands of Facebook applications. The folks at Facebook need to protect a lot of their data, so they don't make a lot of the data within Facebook public. Some of it is, some of it is not. You guys, all your stuff can be public. That will grease the wheels of your project. But you do need to differentiate public and private methods when you go at it. So let's go back to the core goal of your program, where you need to set set the price and your IPO quantity using random numbers to initialize your first stock. Good stuff.